Okay, guys, welcome back, and welcome to the fourth quarter. This is it. We got about 11, 12 weeks left, and you're done for the summer. And we're going to start off the fourth quarter strong, and we're going to start with chapter 10. I do not like the way the book starts off this chapter. I don't think that it's a logical progression. So we're going to jump around a little bit. We're going to go in the order that I think is best. And I'm also going to add a section later on, if you check deadline, that is not even from this book. Okay, and I'll give you a printout for the homework for that. Okay, but today we're going to start with circles. Okay, and a circle is a conic section. Now, why a conic section? Why is it called a conic section? Because if you were to take a cone, okay, and cut that cone in half, put a cross section around it, you're going to have different shapes, such as a circle, an ellipse, a parabola, and a hyperbola. All of those shapes come from a cone. Okay, so circles come from these cones, so hence they're called conic sections. Let's look at a couple examples of these. For example, here for the circle. If you look at the cone here, if you were to put a flat plane, which is this guy right here, through the cone, you're going to get a circle, okay? So that's where this circle comes from. If we proceed throughout the chapter, we're going to be seeing ellipses, which is kind of, you know, an oblong kind of circle. We're going to be seeing parabolas, which we have already visited, which would be this guy right here, parabola. And we're going to be seeing hyperbolas, which come this way and that way. So we're not going to be really working with these cones, but it's good to be able to at least understand where it is that each of these shapes are coming from. Okay? So this is where a circle's coming from. It's coming from a cross section of a cone, literally. Hence, they're called conic sections. So, okay. So now let's get back to our circle. A circle, my friends, is any set of points that are equidistant from the center point of the circle. Am I recording? Yeah, okay, good. I thought I had. Okay. The radius of the segment is a segment that is equidistant from the center of the circle to any point on the circle itself. Okay, so in this particular case, I should have done this red, so I'm going to change this so it doesn't confuse you later. That's red. That's red. And that is blue. Okay, so the radii, or the radius, is a segment that goes from the center, okay, to any point along the circle. All of these are radii. And guess what? Since they're all radii of the same circle, all radii are always congruent. They're all equal. Very good. Okay, so those are radii. It's any segment that extends from the center of the circle to any point along the circumference of the circle. Please remember that when I say circumference of the circle, that means on the circle itself. Circumference is basically perimeter for a circle. The circumference, let's say I start here, circumference is basically, not basically, it's exactly the distance around the circle. It is a linear measurement, and if you remember, circumference equals 2 pi r. That's just a little side note. We're not going to really be dealing with too much circumference, but we may have to figure out what the radii is, or what the diameter is. So circumference is 2 pi r, or diameter pi. How can you interchange? Well, that's because of these guys over here. Diameter is 2 times the radius, and radius is the diameter divided by 2. Now, what is this diameter? The diameter is any segment that goes from one point on the circle to another point on the circle through the center of the circle. So you're starting at one point of the circle, going to another point on the circle, but you went Bam! Through the center. If you do not go through the center, if you were to go this way, again, it's not that important for this lesson, but just to teach you, when you have a segment that does not go through the center, that's called a chord. You're going to learn that later in geometry, but now you have a little heads up. Okay, if the segment goes from one point to another point through the center, it's a diameter. If it goes from one point to another point and it does not go through the center, that is called a chord. Okay. So that in a nutshell is a circle, what it's made up of. All of you guys have probably seen this before, maybe not in such great detail, but this should be relatively familiar. Please again remember, diameter equals 2 times the radius. Radius equals diameter divided by 2, and the circumference equals 2 pi r, which is 2 times pi times the radius, or diameter pi. You may need to know those formulas because sometimes they'll give you the circumference of a circle, and they want you to write the equation for the circle, but you first have to find out the radius. So these are good formulas to know. Yes, sir? You could use both or either, sir. For example, they said, you know, the circumference is 50 pi. They say the circumference is 50 pi. Find the radius. Well, you know that 50 pi equals 2 pi r. So if you divide by 2 pi here, you know that your radius is going to be 25 units, whatever it is, inches, centimeters, feet, yards. Thank you. Good question. Or you could have still said, okay, 50 pi equals diameter times pi. Well, if you divide by pi, my friend, you know that 50 is your diameter, but then you know that your radius has to be half of that, so that would be 25. Either way. So yes, the answer is yes. You could interchange. Does that make sense? Thank you, sir. Okay, so we saw that. Okay, now, when we talk about a circle, my friends, we're going to be talking about a circle in what's called standard form. In fact, we're going to be writing the standard form of all of the conic sections: circles, parabolas, ellipses, and hyperbolas. I just wanted to show you where these values are coming from and how you can kind of like assign them in your head. The standard form of an equation, okay, of a circle, of an equation of a circle with center hk and radius r is x minus h squared plus y minus k squared equals r squared. Now, from the function of libraries, does this h and does this k remind anyone of anything? What does that remind you of? What does the h remind you of? Come again? What does the h do? Well, we're talking about vertexes, yeah, but think about the library of functions and the whole transformations. What does the h shift? How does it shift? Shifts left to right, correct? And how does the k shift? Up or down. So if you think about this, you had a circle here in the center, okay? Didn't I go to the right? Right? And didn't I go also up? Okay, I went to the right h units. I went up or down k units. Remember that these values are, it's an x minus h. So if you see x minus 5, the h is positive 5. If you see h plus 5, then the h is negative 5. Remember, guys, that they're always opposites, correct? Okay, so that's what's happening here. We're not going to do Mickey Mouse shifting like that where we do original and then we shift it up and down. That's kind of Mickey Mouse when you get to conics. We're going to show you a much quicker and more efficient way, but I want you to understand, why did it move to the right? Why did it move up? Why did it move to the left and down? Why, Mr. Morrow? Because of that h and that k, all right? And then what is the x and the y? Well, the x and the y is any particular point P on the circle, okay? And this point P, remember, is equidistant throughout the whole entire circle because the distance from any point P on the circle to the center of the circle is r. That is my radius. You guys with me so far? Okay, pretty simple, right? Yes, sir. I'm sorry, sir? Do I want you to bring compasses? I mean, you can if you want to, but no, I'm not looking for perfect circles. I'm looking for perfect points, and you'll see what I mean. Thank you, sir, for your question. But you absolutely can bring a compass if you want to, and make them really perfect. That's fine. Thank you, sir. Now, let's talk about how we graph a circle first, because that's the easiest part, in my opinion. Hey, first of all, you find and graph the center of the circle, the HK. You find the HK, you graph it, you're done. Number 2, you find the radius. Remember, when they give you the equation, this 16 that they're giving you here, that's r squared. So how do you find the radius? It's the square root of the given constant value. Remember that. To find the radius, it's the square root of the given constant value. And once you find that radius, that r, not r squared, but once you find that r, you're going to move that many units up, down, left, and right from the center point of the circle. You connect the points and you're done. For example, what is the center of x squared plus y squared equals 16? What is the h and the k here, guys? Okay, how are you getting negative 2 and 3 here for a, guys? We're working with a. What is the center here, my friends? Okay, whoever's saying 4, isn't that the radius squared? Remember the formula, guys. X minus h squared plus y minus k squared. My friends, if I only have x squared, what was the value of h then? 0. If I only have y then, what was the value of k, sirs? 0. So again, what is my center? What is my hk? 0, 0. Is everyone with me? Is everyone with me? So 0, 0. Now, 16 is r squared. So what does r equal? 4. It's the square root of the given constant. Okay, the square root of the given constant. So now I'm going to literally go up 1, 2, 3, 4. Literally to the right, 1, 2, 3, 4. Down, 1, 2, 3, 4. And to the left, 1, 2, 3, 4. I'm going to do the best circle that I can. I know that that's more like an ellipse or an egg than a circle, but for our purposes, that is correct. If you did have a compass, and you put your compass point right here in the center, and you lined it up with any one of the points that you graphed, just go ahead and follow that compass around, and you'll have a perfect circle. But for our purposes, as long as you can identify and graph the center for me, identify and move the radius appropriately, connect the dots, I will accept it. Now, I'm not going to accept it if you guys go like that, okay? So please don't be funny about it, but just try to the best of your ability, the best circle possible. I don't think that was a great circle at all, but it's totally acceptable circle. May I continue, gentlemen? Okay. Number 2, what is so steps always, you're going to first go like this. Center. What is my center? Negative 2, 3. Because remember, this is x minus h. So if it's x plus 2, that means h had to be negative 2. Because a negative times a negative is a positive. Remember, this is y minus k. So if k is 3, then that means, if it's y minus 3, that means k has to be 3. Because a negative times a positive is a negative. Does that make sense, guys? Yeah. Step 2, what's my radius? 5, done. My center is negative 2, 1, 2, 3. And then I'm going to go up 1, 2, 3, 4, 5 from the center. 1, 2, 3, 4, 5 to the right from the center. 1, 2, 3, 4, 5 down from the center. 1, 2, 3, 4, 5 to the left from the center. The best circle I can possibly draw, which again is not that great, but it is totally acceptable. Does that make sense, gentlemen? Pretty simple, right? Pretty simple. As long as you see why we learned the library of functions before this, because I wanted to show you guys, give you an understanding of what this h and k did. This h shifts it to the right or to the left, and the k shifts it up or down. If you think about this again, in a regular circle, a regular, standard circle, it's x squared plus y squared equals r squared, right? Well, think about it. The center in one of those would be right here, okay? Didn't I shift that center 2 to the left and 3 down? Oh, wait a second. What? I'm sorry. Two to the left and 3 up. I'm sorry, because that's a positive. And yeah, look. 1, 2, 3 up. See what I did there, guys? So that's what's happening here. You don't have to ever shift it and do a parent graph and then shift it, but I want you to understand the concept here, because if you know that this is being shifted 2 to the left and 3 up, then you know if you end up with a circle over here that you're wrong. That's why I'm trying to make you guys put those pieces together. Does that make sense? Okay. So another one, gentlemen. Okay, what is the center here? First step always, center. Please label this, guys, as well. Labeling for conics is going to be huge. That's half the battle in the quizzes and the tests as well. Sometimes you label it correctly and you graphed it incorrectly, you're going to get a lot of credit. If you graph it correctly and you don't tell me how you got it, if you don't label, you're going to get 0 to no credit. So you got to label, please. So the center again equals 5, 3. Just for giggles. From the center, what does that mean? How am I shifting this circle? To the right 5, up 3. Thank you, gentlemen. Awesome. Okay, what's my radius, gentlemen? 3. Done. So 1, 2, 3, 4, 5. 1, 2, 3. That's my center. Up 1, 2, 3. To the right 1, 2, 3. To the left 1, 2, 3. Down 1, 2, 3. Connect the dots. I don't know about a good circle, but it's decent. Sir. No, they're not always going to be this pretty. They could be ugly. I could give you x squared. Let's say I give you x minus 2 squared plus y minus or plus 4 squared equals the square root, or how about that? Let's do that. 13. Okay? If we do that, then I know my center is going to be very good, son, 2, negative 4. And I know that my radius is going to be, look at that, I put instead of 2r. So number 2, so you have r equals the square root of 13 in this case. Okay, now, what is the value of the square root of 13? Okay, in real life, you'll be able to use a calculator. I don't like using calculators here, so this is what we're going to do, just so you can get an idea of where to estimate this, okay? My friends, isn't this between the square root of 9 and the square root of 16? So shouldn't this number be between 3 and 4? So if I were to graph this, this is about as strict as I would be in this case. Because again, in real life, if you were going to do this as an engineer, you'd have some aids. So I'm not here to make it difficult. The center was 2, negative 4. So 2, negative 4 is my center, okay? And I know my radius is square root of 13. So that's between 3 and 4. So I'm literally going to estimate between 3 and 4. Okay, so basically between 3 and 4, it's about 3.5, right? So I'm literally going to go 1, 2, 3.5. 1, 2, 3.5. 1, 2, 3.5. 1, 2, 3.5. Is that an exact circle? Wait, absolutely not. Not because of the way I drew it, but because I'm estimating. I am estimating. So in essence, I'm kind of sketching this one because I had to estimate the radius. But if you had a calculator, okay, or you were doing this on a program, you know, you're on your iPad, you're working at a job site, you're making a circular entrance for a well, or a circular entrance for, I don't know, a bridge or a tunnel or something of that nature, you would have everything perfect to the decimal. But you would need to know how to work it, and this is how you would work it. But for our purposes, is this fair? Okay. Thank you for that question, son. Good question. Yes, sir.
If you had a negative number where r is, would you use I or would
Okay, the question, very, very good question, son. The question was, would I have a negative number? If I said x squared plus y squared equals -7, you can't do that. That will not be a real circle. Thank you, sir. Yeah, you would put not possible. I'm not going to give it to you. But if you saw that, that's not possible in a real number line. That would be an imaginary instance, and we're not at that math yet. Okay? Thank you, sir. Now, writing the equation of a circle. Still easy, a little bit more complicated though. There's situation number 1 that is in red. This is the Mickey Mouse one. When given the center and the radius, simply plug in the h, the k, and the r squared. Remember, square the value of r they give you, into the standard form of the equation of a circle. So what is the equation of a circle with a center of -5, 4, and a radius 3? Okay, guys, take a seat. This is going to be hard. Ready? It's going to be x plus 5 squared plus y minus 4 squared equals 9. That's it. Done. I was being a little sarcastic there. This is really easy. It's Mickey Mouse. Okay? Does that make sense, guys? Where we always mess up, though, is in the signs. Please, gentlemen, remember that it is x minus h squared plus y minus k squared equals r squared. Please commit that to memory. That's where I get most of the mistakes. Example 3, what is the equation of a circle with center 4, -3, and radius 6? Talk to me. X minus 4 squared, yes? Plus y plus 3 squared equals 36. Oh, yeah. Good job. Great. Does that make sense, y'all? Pretty simple, right? Okay. Now, here comes the fun. When given a polynomial representation of the equation, you must complete the square for both the x values and the y values. Good news. We've already completed the square to solve a quadratic function. We've already completed the square to rewrite an equation of a parabola in vertex form. So the skills are all there. Let me just hone them in for you today and just show you how to attack this. Boom. So you can just knock this out whenever they give it to you. Okay. First things first. Always isolate all the x's on together and get the y's together and get all the constants on one side. Remember that the constants are numbers like this guy right here, 8. Any number that is not attached to a variable. So I'm going to get the x squared over here plus the 8x, and I'm going to leave myself some space because remember I'm going to have to complete the square. Then I'm going to go y squared, no, not plus, but minus, thank you, sir, 10y. I'm going to leave myself some space, equals 8. That's the setup I want. I want to get the x squared and the x together. I want to get the y squared and the y's together. And then I want to get the constants on the right side. Okay, in this case, the 8 was already there. If it was jumbled up with the x's and the y's, you would have to move it over via opposite inverse operation to the other side. So now, please pay attention. We have to complete the square for x, and we have to complete the square for y. These numbers are pretty. I'm not going to purposely put nasty numbers, but sometimes there are nasty numbers. So please make sure you got your fractions in check. So let's do it. I'm going to complete the square here. So b over 2, that's 4 squared. I'm going to do like I always did. Keep it like that. But I'm going to add it over here. I do it step by step. Remember how you always have to add to the other side, right? Remember when we were doing a vertex form, we subtracted it just to keep it all together. But we could have added it to the other side and then subtracted it back. Let's complete the square now for my y. My y is going to be -5 squared. So plus a -5 squared. Now from here, all of those practice problems that we had done hopefully will all come together now. Remember, this is the square root of the first and the inside. So plus 4 squared. Done. Plus y inside minus 5 squared. Excellent, guys. And that's going to equal 25 and 16. No, 25 and 8 is 49. It's going to be 49. 49, guys. 25 and 16 is 41. 41 plus 8 is 49. Now, just out of curiosity, if I ask you what is the center of this circle, what would it be, gentlemen? Negative 4, 5. Done. What would the radius be, gentlemen? Awesome. Pretty good, right? It's not that bad, right? Why don't you guys write that down instead of, look at it. Check it out. Okay. Here, better yet, why don't you guys do this next one for a second? I'll pause the screen so that people at home don't have to be bored. And let's see if you got that. All right, guys, y'all did well. Y'all did really well. Okay, what's my equation here? Well, actually, let me go through it. Sorry for the viewers at home. Everyone got it right here, though. Very good. So I'm going to go x squared minus 6x plus. I'm going to go ahead and complete the square now. So that's negative 3 squared plus y squared plus 14y plus. I'm going to go ahead and complete the square right now. Good job, 7. Very good. Squared. That's going to equal 8 plus the completed square for x plus the completed square for y. That's going to give me exactly like you guys said, x minus 3 squared plus y plus 7 squared equals 66. Very good. The radius, well, the center, let's talk about it. The center here would be 3, negative 7. Excellent. And the radius would be the square root of 66, which when we're graphing this, guys, that's going to be between 8 and 9, but closer to which one? Really closer to 8. Okay? Yeah, it would be like 8.1. 8.2 is exactly correct. Okay? Does that make sense, guys? Awesome. Then we are done. Awesome. Thanks a lot, guys. Let's do some practice now.